Sometimes in math and physics, you run into a troubling expression like this: the sine of one angle multiplied by the cosine of another angle. And I may be trying to re-express it in order to gain a physical interpretation, or I'm trying to simplify it in a way that makes an integral doable in calculus. And this requires a special class of trig identities to get it done. So this one comes from looking at the sine of a sum or difference of two angles. So the sine of theta plus phi is sine theta cosine phi plus cosine theta sine phi. That doesn't look like a theta. There we go. Well, sort of. If I then look at the difference of two angles, sine theta minus phi, I get sine theta cosine phi minus cosine theta sine phi. And the whole point of this is to exploit the symmetry of these formulas by adding them. And what I'll get on the right hand side is that these two terms cancel out. And I end up with twice a sine of one angle and a cosine of another angle, which is exactly the kind of thing I'm looking at. So I end up with sine theta plus phi plus sine theta minus phi is twice the thing I'm trying to get an expression for, and all I have to do is divide by 2, and I come up with a useful new identity. So it's going to be the sine of one angle, cosine of another angle is 1/2 times the quantity sine of the sum of the two angles plus the sine of the difference of the two angles. And that's one that I've never had memorized, maybe just because it's so ugly, but I'll quickly rederive it if I see a situation where I need it. So let's apply this. This means the sine of 2x cosine of 3x is going to be 1/2 sine of, so I'm letting theta equal 2x here. Phi is 3x here. So I have the sine of the sum of those two things, which is 5x, plus the sine of the difference of those two things, 2x minus 3x. Since the sine function is odd, we can clean this up a little bit and call it the sine of 5x minus the sine of x. So if you imagine that you're seeing something like this inside of an integral, there's no way to do that directly. Now that I've transformed it like this, I can do two integrals and they're both simple.